Welcome to the class of antenna and wave propagation. Here we'll start with the video lecture number 8 and we'll start with the electric field due to continuous charge distribution. In the last lecture we have studied about the force between the two charges and the electric field intensity. Now here today we'll start with the electric field due to continuous charge distribution. Now electric field due to continuous charge distribution. In the last lecture we have studied about that there will be some point charges. Some point charges 1, 2, 3, 4 any. Okay. Now if I say this is a surface and this surface has a number of charges which may be infinite, which are infinite, or I say this is a volume, this is a volume and this volume has number of infinite point charges, or I say this is a line and this line has a number of point charges. So that is known as the electric field, and that is known as the charge distribution along a along a surface, along a volume, or along a line, and this one is the point charge. So this one individual charge is known as the point charge, and the number of charges present along a line, that is known as the line charge, which is this rho L is the what? Line charge density. Line charge density. This line charge density means number of point charges per unit length. Number of point charges per unit length. Clear? And this one is the surface charge. In this surface charge density, that is denoted by rho S, that is surface charge density, or this has a unit of coulomb per meter square. You can say that number of point charges per unit surface or per square meter, or you can say per unit area. Clear? And similarly for this one is rho V, that is the volume charge density, it is number of point charges per unit volume, or this will have a unit of coulomb per meter square and this have a unit of coulomb per meter cube. Clear? So now if I say, if I want to calculate the total charge along this line, that is denoted by what? Q, total charge along this line, that is Q. And just if I divide this line into a smaller part, let's say this one is known as DL, length is DL. Clear? This length has a DL. If I say this length has DL, has a charge, length has a charge, that is dq, that is dq, then you will say that this dq will be equal to dl multiply में line charge density, that is rho L. Clear? And this q will be, then I want to calculate the total charge along a line, that will be q will be integral of rho L multiply में dl. Clear? So similarly for this one, q will be equal to rho S ds, and similarly here q will be equal to volume integral of rho v dv. Clear? That is q equal to rho into me v into me dv. That is dq equal to rho s into my ds, that is surface integral. You can say that it is also rho s ds, and this rho v dv, that is q equal to volume integral of rho v into my dv. You can say that is rho v dv. Clear? Now if I want to calculate the electric field along a line charge, that will be, this is what, q, that is rho l dl upon 4 pi epsilon. You know that E equal to what, force upon me q. Clear? Then if I know that this is q, that force, you will see that you will see q1 q2 upon me. Similarly, number of point charges, that is will be q1 4 pi epsilon naught r square, sorry, r cube की power में, sorry, this one. At this point, that is rho l dl 4 pi epsilon naught r square a cap r plus में electric field due to surface charge, electric field at a surface charge, that is rho s ds upon 4 pi epsilon naught r square a cap r. Electric field due to volume charge, that is rho v dv upon में 4 pi epsilon naught r square a cap r. Now this one is the question. I want to calculate the electric field at point P due to a line charge present on positive z axis. Clear? Now if I say this is a point P, I want to calculate the electric field at point P due to the presence of line charge density, that is AB, along a z axis. Now first you will see that there are number of point charges along AB, number of charges will be there. So the electric field due to a lower point, that is will be this one in this direction, and another will be in this direction. Now if I take a small length of this point charge, that is small length, that is dl, and this dl has a charge, that is dq, and this dl has a distance vector, has a distance between point P and this length is denoted by r vector. Clear? And this one is the perpendicular distance from P to z axis, that is denoted by rho. Clear? Now see, dq will be, this dq will be rho l into my dl, that is rho l into my dz, because it is along the z axis, and this this point will be have a coordinate of 0, 0, z dash, means this z dash is this one. Clear? Now we will see that q will be what, overall charge present in this line, that is q equal to za to zb rho l into my dz. Now this dl will be what, dz dash along this line, that is dz dash, itna sa part. Clear? R vector, this r vector is equal to what, x y z, this has a coordinate x y z, minus में this coordinate 0, 0, z, that is will be x into में a cap x, y cap y, a cap z plus में z minus z dash a cap z. Now see, now I want to calculate the electric field at this point. See, clear? Now electric field is what? For finding the electric field, I just want to have a value of r1, this distance and this distance and this r. So r will be equal to, now from this point, from this angle, you will see that r vector equal to rho into में a cap rho z minus z a cap z, then r square, r vector square will be equal to x square plus में y square plus में z minus z का dash का whole square equal to rho square, then a cap r divided by r square equal to will be what? Just divide this equation, you will get this one. Clear? Now as we know that electric field is equal to what? Electric field क्या था? You have seen that electric field rho L dl 4 pi epsilon r square a cap r. This can be written as rho L dl 4 pi epsilon naught r cube multiply में r vector. Similarly, I want to calculate, I have find out a cap r divided by r square or r vector divided by r cube, that is will be equal to this one. Now just put this value in that formula, you will get electric field at this point. Now see what? See this r vector is equal to rho square z minus z dash का whole square की power में 1/2, that will be equal to, now if I just rub this and see this one, this is along this path, this triangle, you will see that will be rho into में secant alpha, capital R, this capital R will be equal to rho into में secant alpha, and z dash, now see from this one, now z dash equal to OT minus में rho into में tan alpha. What is OT? This one. And this OT, z dash is what? This one. This z dash equal to OT minus में this one. This is z dash. OT minus में this one will be a z dash, and this one is what? Rho into में tan alpha. So dz dash, just this one. G dash, OT is a constant, so just it will get differentiation of OT will be 0, that is equal to minus rho into में secant square alpha into में d alpha. Just put this value, you will get electric field at point P will be equal to this one. What is alpha and alpha 2? This is a angle making from alpha 2 from point P, and this is alpha 1. Clear? Now if I say for the finite line charges, just put this value, just so integrate this value, you will get this one. For infinite line charges, you will see that alpha 1, for infinite line charge means this is goes to minus infinity and this goes to plus infinity. You will observe that what? Alpha 1 become equal to pi by 2, just like this one, and alpha 2 become minus pi by 2. You will get E equal to rho L upon में 2 pi epsilon naught rho into में a cap rho. So this one is the electric field due to a line charge density. Now I want to calculate the electric field at point P due to a surface charge. Means if I say this is a surface present along this, and I want to calculate the electric field at point P due to this, and this surface has number of point charges. Clear? So here we will find out this one. Now see, I'll just, if I take only 2-point charges, initially I'll take this 2-point charge, that is this one 1 and this one 2. These are along the line, and this has a cap rho is in this direction, and this has a cap rho in this direction, that is minus of a cap rho. Clear? Now in this has a cap phi in this direction, and this has a cap phi is in this direction at this point. Now I want to calculate the electric field at point P, means on the z axis, which has the coordinate 0, 0, h. For simplicity I have taken 0, 0, h. So now just take that small charge, that is, if I say that is dq, and it covers a surface area, that is ds. So dq will be equal to ds. You will see that dq will be rho s into my ds, and therefore total charge will be equal to q into my rho s integral of rho s into my ds. And this, if I say this from this point charge, the distance between this point P and this one is r vector, and this one is the height, that is denoted by. So at point P, electric field at point P due to only this charge will be equal to dq upon my 4 pi epsilon r square a cap r. Now I want to calculate the r vector in terms of h, okay, and I want to calculate the a cap r. You will see that a cap r will be r vector divided by r magnitude. Clear? And r vector will be equal to what? Now see this one, r vector will be equal to this one. Just take this triangle. You will get r vector equal to rho into my minus of a cap rho plus my h into my a cap z. You will see that r vector equal to rho square plus my h square की power में 1/2. Clear? So dE, now just put this value, a cap r and r square, put this value, you will get this one. Now see, there will be a term dq equal to rho s into my ds. Now what is this? How this ds will comes out to be d phi into my d rho, rho into my d phi into my d rho. You will see that this is this plane, and this plane has a surface vector in which z is constant, and these two are the variables. In the vector calculus we have studied that this ds will be equal to rho into my d phi multiply my d rho. Clear? Now see, now for I want to calculate the electric field at point P. Due to this I have taken that this is due to this point P. Now if I want to calculate the whole electric field at this point P due to all point charges, that is dE equals to, just integrate this integral of dEz. You will see that phi will vary from 0 to 2 pi and rho will vary from 0 to infinity. Clear? Now on integral you will get this one, electric field at point P will be equal to rho s upon by twice of epsilon naught a cap z. So for the infinite sheet of charge in which I have taken rho 0 to infinity, that is E vector equal to rho s a cap n upon by twice of epsilon naught. Now for the parallel plate capacitor. Now for the parallel plate capacitor, you will see that the electric field, that is rho s upon by twice of epsilon naught a cap n plus minus of rho s twice of epsilon naught minus n, that will be equal to this one. How it will come? You will see that if I say this is one surface having some charges, and for the parallel plate capacitor along this surface there is also another charge will be there having a negative charge. Let's say this have a negative charge. Clear? And this is connected to what? Battery. Now if I say this as a positive charge, as a x-axis or y-axis or z-axis, so here it is defined at P, and I want to calculate the electric field at point P in between the 2 point charges, 2 parallel plate capacitor. You will see that this is a positive x-axis, rho s into me twice of epsilon naught a cap n, this one. For the negative charges, electric field will be in this one. Clear? So you will get minus of rho s upon me twice of epsilon naught minus of a cap n to this one. Clear? You will get that rho s divided by epsilon naught equal multiply में a cap n. So this one is the electric field due to a parallel plate capacitor between the 2 parallel plates. Now I want to calculate the electric field due to volume point charges, volume charge that is present on this one. You will see that electric field at this point charges will be equal to what? Similarly to a point charge, because this volume, when I say this volume, it shrinks to some point that is P. So overall point charge at any point on the volume will be equal to Q upon 4 pi epsilon r square a cap r. The book I have referred for preparing the slides, that is Principle of Electromagnetics by Matthew and Sedico. Thank you.